Good morning, friends. Today is yet another Sunday morning session at 9 a.m. IST for students who are interested in GATE 2027. So, this is a weekly session by volunteers who are interested in sharing whatever knowledge they have with other students who are keen to prepare for GATE 2027. Today's session is conducted by Ashwin G. Rao, 8th semester final year student of Sri Madhu Adraja Institute of Technology, Bantakal. Thank you, Ashwin, for your gracious presence for this session. Over to you.
Thank you, sir. Thank you for the opportunity to present calculus topic. Let's begin. So, why calculus? This is the two big ideas that change the world. The two ideas were differentiation. How fast is something changing at an exact instant, like finding slopes, velocity, rate of change, and integration. How much total change that accumulates over time, which includes finding areas, total distance, total growth. Fundamentals is the two inverses. These two are inverses of each other. As you can see here, this is the integration generalization of the integration symbol. So what is the main topic is, if you imagine looking at a curved road on a Google Maps, when you zoomed out, the whole road will curve gently when you observe the road. When zoom in a lot, that tiny piece of that piece of map or direction will looks almost straight. When zoom in even more, it is straight for that tiny piece. Calculus in that says that zoom in infinitely close tends to curves looks like a straight line. That slope of that line is equal to the derivative of that point. As you can see here, let's present. As you can see here, this is the curve of that point. Same probability. This is the tangent line. So what is tangent? Tangent is the point where the curvature meets the line of that circle curvature. Line of the point. Line which is present in the point which is present on the line. As you can see. Derivative is like this: y2 minus y1, x2 minus x1, which is also represented by dy by dx, which is nothing but y2 minus y1 x2 minus x1. This is the general representation. So why do we need this to solve this? It is involved in physics also. It's involved in economics also. It's involved in biology, which is the rate of the growth of bacteria, and it is the derivative of that population. You can find out rate of change of that growth, and it is also used in optimizing the design, finding derivative and zero. And every engineering entrance exam tests calculus every. What are the prerequisites you want to know is algebra, trigonometry, coordinate geometry, functions, and graphs. In most of the previous session, we covered algebra, functions, and graphs. Still, trigonometry and coordinate geometry is remaining. We will cover some basic session. So, what are the languages of calculus? Is functions. So, what is a function? Why do we write f of x? The symbol f stands for function. It's a machine that takes an input and gives an output. Think of it as like a vending machine. You put X, code for a snack, then machine processes it, and out comes f of x, the snack. The key idea is f of x is not f times of x. It is f of x, the value of the function f at that point x. Why do we use delta as change? In calculus, we often talk about small changes. The Greek letter delta means changing. Delta x equal to change in x. If x goes from x1 to x2, then delta x is equal to x2 minus x1. That difference is called delta x. Similarly, delta y is equal to f of x2 minus x of x1, change in function of the value. As you can see here, this is the change of the value, this is the line slope, and secant slope is delta y by delta x. This is the derivative you have to find. Basically, you are finding throughout the calculus, in differentiation, you will find delta y divided by delta x. It is nothing but dy by dx. These are some types of function you must know: polynomial, rational, trigonometric, exponential, and logarithmic. These are the inverse functions: f of x sin inverse of x, f of x tan inverse of x. Then you can go with the limits now. So, what is limits? These are the foundations of calculus. Why do we need this? Imagine you are walking toward a wall. Normally you are walking towards the wall, or normally walking in a way. You get closer and closer. How close you can get? As close as you want, but you might not actually touch it, because if we touch it very hard, we get bombarded with it. We can experience pain. That's why. That's a limit. What value does something approach as you get arbitrarily close to some point? It is called as a limit. The notation is limit. Notation is, let's see here. Limit x tends to a f of x which is equal to L. Some function L. What E symbol means? Limit is short for limit. Lim. X tends to a, x approaches a, gets arbitrarily close to a but not necessarily equal. F of x is the function what we are looking at. L is the value of that f of x gets close to. Read it as the limit of f of x as x approaches a is L. If in simpler terms, as x gets to closer and closer to a from either side, f of x gets closer and closer to L. So how do we understand more? Look at f of x, x square minus x1. This is the graph. What happens when x is equal to 1? When x is equal to 1, function a gets undefined. So that's why it comes 0 by 0 undefined. So what happens when it gets close to 1? Why not take one? There is a hole, but limits don't care about what happens at that point, but only what happens at near that point. As you can see here, this is the more infinitely different points. As you can see, this is the what happens is there. So moving on to left hand and right hand limits. So the definition is left hand limit. Take your left hand. What that representation is, limit x tends to a minus f of x. X approaches a from the left. Like if you consider a as 1, then limit x tends to a minus is x approaching a from left. Value is less than a. Obviously, this is 0 is less than a, minus 1 is also less than a. And also right hand limit x tends to a positive f of x, x approaches a from the right, value is greater than a. Imagine a is 1, then limit what approaching is 2 or 3, this is approaching to 1, which is greater than a. These are left hand and right hand limits. Any doubts so far? Okay, so no doubts so far, I guess. I will go with numericals. So examples, let's go with numericals. Limit, what they given is limit extends to 0 mod x divided by x. How we represent it, the left hand limit? Let's see. For x tends to 0, which is from negative side, left hand limit we get is mod x is equal to x. Why? Because whenever in mod x in minus value like minus 5, it will get positive when it is in modulus sign, mod sign. That's why. Okay. So what about greater than for less than 0? It will get positive. Sorry, for left hand value it get positive. For left hand value it gets negative, I guess. Let's move do it again. X a minus is tends to x equal to minus x, as you can see here. So the mod x divided by x is equal to minus 1. This is the graph. Right hand limit is x tends to 0 positive, modulus x divided by x equal to 1. Since minus 1 is not equal to 1, limit x tends to 0, modulus x divided by x does not exist. For limit to exist, they should be equal. Left hand limit and right hand limit should be equal. Then only we can compute for most of the properties. These are the different properties you have to remember to solve our problems. You can for solving the limit, I would suggest that you should direct substitution. Like if there is this function 3x square plus 4x minus 1, just substitute and compute the value. Why does this work is polynomials and many other functions are continuous. Their graphs have no breaks, jumps or holes. For continuous functions, the limit equals the function value. As you can see here, this is also a polynomial. This is also a polynomial graph. This is also a polynomial graph there. There you can actually get continuous graph and actually compute where some value will be given. Some value you will get, and that will equals the function value. When direct substitution gives 0 by 0 indefinite form, you have to factorize it, like limit x tends to 2 x square minus 5x plus 6 x square minus 4. When we substitute 2 here, it will get 4 minus 10 plus 6, 4 minus 4, 0. It is indefinite. We should not stop here because 0 by 0 is meaningless. It could be anything, 0, infinity, 5, whatever. We need more information. So that's why for factor both numerator and denominator, x square minus 5x plus 6 is represented by x minus 2, x minus 3, which is imagine these are the normal forms. It is like x square minus, it is like a square 2ab plus b square, which is nothing but a minus b whole square. This is the formula. You should be remember it. Next, moving on. Next concept. So x minus 2 is what we causing the problem. This it makes 0. By cancelling it, we will get revealing underlying behavior x minus 3 divided by x plus 2. You have to factorize it also, this also, which is nothing but x square minus 4 is nothing but x plus 2 x minus 2, which is like a square minus b square, a plus b into a minus b. This is nothing but general formula. This is to remember it. Okay, next go into next the what is step is we can cancel this x2 and then go for a substitute that x2. Then division the substitute 2 over here. 2 minus 3 is minus 1. 2 plus 2 is 4. We will get this minus 1 by 4 where function meets the value. That is the limit of this function. So next method is rationalization for square roots. Same, when directly substitute we get 0. We should not end there. So then what is this? Multiply numerator and denominator by conjugate. The conjugate of x plus 1 minus 1 is x plus 1 plus 1. Why multiply with conjugate? Because square root of a minus b, a plus b is a minus b, which removes square roots. As you can see here, this is the worked example. So we'll get 1 by 2 where function limit meets the limit. Method 3 is using limit x tends to 0 sin x divided by x minus 1 is equal to 1. Why? Let's understand it geometrically. This is the sin x divided by x graph with representative x graph. Consider a circle of radius 1 for small angle x in radians. Sin x is a vertical line from the point on the circle on x-axis, as you can see here. X is the arc length along the circle. As you can see here, this is the arc length of the circle. For very small angles, the vertical line and the arc are almost the same length. So sin x divided by x is almost equal to 1. Why radians is the limit only works if x in radians. In degrees, limit x tends to 0, sin x divided by x is equal to pi divided by 180, which is not equal to 1. Calculus always use radians. Please remember that. Why this is useful is many limits with the triangular function reduce to this one. These are the other important standard limits. These are the work that example you can choose here also. Okay, next case is limits at infinity. How do you calculate that? So this is the continuous, this is the jump discontinuity, and this is removable. Why? As x gets huge, 1 divided by x gets tiny. 1 divided by 1000 is like this, etc. General rule for the rational function is divide numerator and denominator by highest power of x in the denominator. Here, highest power in this problem, the highest power is x divided by x square. So we are dividing it. When divided, we will get this expression. Because of that, we will get we can compute it. We'll get answer 3. Y divided by x square is because the terms like 2 divided by x and 1 divided by x square goes as 0 as x tends to infinity, leaving only the leading coefficients. As you can see here, this will get tiny, right? That's why it will only leading to coefficients. As you can see here. These are some practice problems. Same, you have to factorize it or direct substitute it and understand it geometrically. From that, you can actually understand it. So next goes continuity. Why continuity is a function is continuous if you can draw it without lifting your pen. No holes, no jumps, no breaks. Why this matter is continuous functions have nice properties: intermediate value theorem and extreme value theorem. Differentiability, which requires continuity. Most real world phenomena are continuous. Position also, temperature, pressure. So what is the definition? F of x is continuous at x is equal to a if all three conditions hold. F of a is defined. The function has a value at a. Limit of f of x exists when the left hand limit and right hand limit is equal. And limit extends to f of x is something f of a. Condition 3 is the key. The limit equals the value. Then types of discontinuities are removable, jump, and infinite. You should just remember it, but there is a problem that only asks for limit computation, not just types. They don't ask for types for now. Why continuity matters is every differentiable function is continuous, but not every continuous function is differentiable. Example is f of x is mod x is continuous is x equal to 0, but not differentiable at sharp corner. As you can see here, it's not differentiable. Y is equal to 0. Next, moving on to we get differentiation. Why differentiation? We want to know how fast is something changing at an exact instant. A speedometer doesn't tell you the average over a trip. It tells you speed at each moment. That's a derivative. Like when you speed in a traffic police actually tells you how much speed you get, right? That speedometer doesn't tell you average speed over a trip. It tells you speed at each moment. That's derivative. The derivative of f dash of x, f prime of x it is the slope of tangent of line f of x at x, the instant rate changes of f of x, and how much f changes for a tiny change in x. Why the notation dy by dx is? This is the labeling. One of the inventors of calculus thought of this system. Dy is small change in y, dx is small change in x. The d stands for difference or small change. It's not like a fraction in the sense of d times y, but the notation looks like 1 and often behaves like 1. Example is chain rule. And also first principles. First principles. The definition is f dash of x is equal to limit x tends to 0 f x plus h minus f of x divided by h. Here h is a tiny change in x, like delta x I mentioned right in the first section. These are the notations of them. The key insights, as you can see here, is a slope of connecting that second line. This secret line approach tangent line. The limit if exists is the slope of that tangent, the derivative. This is the partial derivative. You can see dy by dx is equal to dy by du into du by dx. Here du by dx is this x component. This u is equal to g by x. G is equal to x. Then dy by du. This is the whole function y. As you can see here, this is the example problem. Write the definition f of x plus h minus f of x divided by h. Substitute f of x is equal to x square. Expand that x plus h is equal to x square plus 2xh h square. To simplify the numerator, so that we can cancel h. This h component is right. We have to cancel that. Then converting it, we get this expression. Factor h out of it, cancel it since h is not equal to 0. As we take the limit, 2x plus h. Take the limit, 2x plus 0 is 2x. The result is if f of x is equal to x square, then f dash of x is 2x. Geometric meaning at x is equal to 3, the slope of the tangent to y x square is 2 into 3 is equal to 6. Any doubts so far?
Uh, Please go ahead.
Okay. So why the power rule works? This is the from the pattern f of x1, f of x2, f of x3. These are f dash of x. 1 x is equal to 0, constant. The x is equal to 0 is equal to 1. F dash of x is equal to x, 2x1. F dash of x is a cube root, that's why 3x square. It's like in general d divided by dx, x to the power of n is n into x to the power of n minus 1. Using binomial theorem. Binomial theorem is it involved binomial series. We will look into it shortly in the upcoming sessions. X plus h to the power of n is this. You have to remember it. This one. Basic differentiation rule is constant rule. When constant is differentiated, it tends to 0. The constant doesn't change. Its graph is a horizontal line with a slope. Like this here. Constant multiple rule. When it's with multiples, constant remains, but the function changes. F dash of x. Sum rule is f dash of x, b of x. Product rule is UV rule. U dash of x, vx plus ux, v dash of x. Because differentiation.
What is UV rule? What does U and V stand for? Any particular thing?
This document I generated through LaTeX, sir.
Okay. No. What is UV rule? UV, does it stand for something or? Hmm?
This UV rule is just a product rule, smaller form for product rule and difference division rule, sir. This is the corresponding formula, sir. These are the quotient rule. This UV
Oh,
rule is the product rule, short form
okay.
for.
Carry on.
Here's the derivation. You no need to remember derivation. This formula you have to remember because differentiation applies instantaneously. Like it will apply one for ux for in one instant. In another instant, it apply for vx. That is the rule. This is the derivation. The next comes is quotient rule, same as product rule, but the difference is u dash vx minus ux v dash f. Minus is low d minus I in the low over low derivative of high minus high derivative of low over the low square. Why here product is plus is it will product will always give plus, but the quotient always gives minus, because minus sign is because v dash decreases when v increases or positive v. It's the change rule. Dy by dx is the change in separate component. Dy by du into du by dx. Why does this work is, imagine a machine with two gears. X gears for X turns gear U, which turns gear for Y. The overall rate is dy by dx, which is a product of individual rates. As you can see here, this is the graph. This is the representation graph.
Wait a minute. Is that the graph correct for this? The gear thing
It's
you
just a representation. This
yeah,
is
you
just a
mentioned the
representation.
gear. Now go to the example of gear.
Yeah, sure.
Uh,
Okay.
yeah, you
Let me.
said imagine a machine with two gears. X turns gear U, and
Yeah.
which turns gear Y.
Yeah.
So, what is the graph for this you're saying?
Imagine this X gear. This is the which turns the gear, which in turn this U gear turns the Y gear. Yeah,
Okay,
as you can see, this is the,
okay,
then like that you can get this product.
okay, okay.
Then goes such chain rule. Why does it then why multiply and not add? Because rates compound. Like in compound interest, when you put some amount, if you changes twice as fast as x, du by dx is equal to 2, and y changes 3 times as fast as x, dy by du as 3, then y changes 2x3 as fast as 6. It's just a reference for x square graph, I guess. Here, here. This problem I represented it first. This is the representation graph. As you can see here, this is the tangent P point. These are the normal, tangent, and then f of x, that function. Let's go understand it with example. Step by step is y is equal to 3x square plus 1 is 5. Let's understand it. So 3x square plus 1 is equal to 5. Identify outer and inner function. Outer function is u to the power of 5. While the inner function is 3x square plus 1. Differentiate outer with respect to the inner. Okay. This is the outer function, right? This is the inner function. So what is the differentiation of outer function? Dy by dx is equal to x to the power of 5. Some of the power rule what we have mentioned. It is nothing but nx to the power of n minus 1. Here u to the power of 5. Here n will become 5. Then what is the x term? Here's only u term and x term. That is the difference. You have to write that u. Then n minus 1. 5 minus 1 is equal to 4. As you can see here, this is 5 is equal to 4. Here u. What is u here? Inner function is you are defined as, if we define u as inner function, the computing will be solved easier. If you don't define that, the computation becomes difficult. You will spend much more time to compute. Just unnecessary trouble. of 4. Then differentiate inner function with respect to x. This u, right? This is x square, 3x square plus 1. Differentiate it. What we will get? Dy by du. No, du by dx. 3x square. What is 3x square? 3 into 2 where x power of 1 plus 1. Plus 1 is where constant. It is constant, right? What happens to constant? It becomes 0. It doesn't have value. It does not change, right? We are only calculating the changes of that function. So answer changes to 6x. As you can see here. Apply chain rule. Dy by dx, dy by du, into du by dx. You'll get 5 into 3x plus 1, 4. Du by dx 6x. 30x 3x square plus 1 to the power of 4. From that we get what is that change we experience this function. Any doubts? These are just derivatives of standard function. You have to remember all these formulas. Will be very much helpful when computing some problems, computing some square roots also. These are just increasing and decreasing components. This is the example problem. You can see here. These are discourses. The local maximum and local minimum. These are just increasing differentiation from second PU concept. Sometimes y isn't right as f of x explicitly. Instead, it is mixed up in an equation like x square plus y square is equal to 25. From that rule, how to find dy by dx? Differentiate both sides with respect to x. We will get 2x into plus 2y dy by dx equal to 0. From that, we will find dy by dx is equal to minus x to the divided by y. Why treat y square as 2y divided by dx? Because y is a function of x. But so from chain rule, we will get this. Only the dy by dx component we have to just be taken care of what we see. Then after that, almost we can solve any question. This is just a representation. Then another concept from PU board is logarithmic differentiation. Take natural log, example y is equal to x to the power of x. Take natural log, a log y is equal to x log x, as you can see from this rule only. This rule only, and you can x log of n minus 1. Here there is no concept constant there, that's why you get log x. Because the exponent down, now the right side of the product we know how to differentiate. 1 divided by dy by dx equal to 1 into log x plus x into 1 by x. This corresponds to log x plus 1. Solve for dy by dx can solve with y into log x plus 1, which is nothing equal to x to the power of x log x plus 1. Y is equal to x by x. It is here example. We will get this expression for dy by dx. Any doubts so far? We'll go for the second order derivatives. No doubts, I guess. This is the second order derivative. A quick reminder. This is rate of change of acceleration, concativity. We will get from this acceleration. So dy by dx corresponds to speed, but acceleration corresponds to d square by d square by y divided by dx. Lend-Lease rule. You can slow. These are applications of derivatives where tangent and normal features. These are the step-by-step explanation you can get here. F of x is then f dash of x, then tangent equation is 4x minus 4. Normal equation slope is minus 1 by y. Increasing and decreasing functions. As you can see here, this increasing and decreasing. We can split the function into increasing and decreasing functions. I find maximum and minimum also same. Maximum profit, minimum cost. This is the oscillating circle. Minimum that curve is at a point of curve upward. The slope goes to negative before to zero. At to positive after the rate of change of slope of positive. F double dash of c is greater than c. How to find maximum minima is f dash of x is we have to differentiate it. Then after that we have to set a value x by x is equal to 0, x is 1 or x is 2. Then find f double dash of x. Testing is critical point at x is equal to 1, f double dash of x minus 6. So it is a local minimum. F of 1 is 5 at x is equal to 6 greater than the local minus 6 equal to local maximum, sorry. Then 6 is greater than local minimum. F of 2 is equal to 4. Then this is the Rolle's theorem. This graph for your understanding. Yeah, continuous if f continuous on a is equal to b, differentiable on a comma b, and f of a is equal to f of b, then there exists at least one constant that belongs to ab such that f dash of c is equal to 0. Why this is true is a continuous function on closed interval attains a maximum and minimum. If f of a is equal to f of b, then maximum minimum must occur at interior point or both endpoints. At an interior maximum, the derivative is 0. This is the Lagrange's mean value theorem. You have to just remember this formula. Derivation that you don't ask generally. This is the then Cauchy's mean value theorem formula. This is then for higher order derivatives, we use Lagrange's theorem. And derivatives is we'll go for Taylor series and some differential equation, third, fourth, fifth order derivative. And understanding patterns helps solve complex problems. This is the notation for generally. It's a standard derivative formula. There are y, get and an example problem. It's the Lagrange theorem. Problem here. Y is 4 is 0 is mainly it involves differentiating problems and computing problems and all. 4 2 is addition only. It's the constant. Uh, there's some problem in curvature feature. I will look into it. These are just the formulas. You have to remember it. In next section, we'll go for indeterminate forms, L'Hospital's rules, and solving some gate level questions, Lorentz series and partial derivation. These are some previous questions. So for next week, we'll go for gate problems and then maximum minima, and for partial differentiation, and for Maclaurin.
Hello. Yeah, we
Yes.
missed the last part. Next week will be gate problems and
Yeah, next week we'll go for advanced concepts.
okay, okay, okay. Thank you, Ashwin. Thank you very much for your
Thank you, sir.
session.